All right, we're looking at the simultaneously example number 18 on page 14 of the packet. Now there's two types of examples I really want to show you here. One of them is they start at different locations and the other one is they start at different times. And we're going to see how those two work. So this one's the different location. So in your packet, a good thing to do, put a little star there and say starts in a different location. All right, so I have runner A and runner B. So let's read this question quick. Two runners start simultaneously, meaning at the same time, at opposite ends of a 200-meter track and run toward each other. Runner A runs at a steady 8 meters per second. Runner B runs at a constant 7 meters per second. When and where will these runners meet? All right, so constant speed. All right, I see constant speed. Constant speed tells me my acceleration is 0 for both of my runners. Now, whenever we set up simultaneous, we need to get them in a common frame of reference, meaning we need a common, where is x equals 0 agreed on, and when is time equals 0. And since they both started at the same time, we'll just call that time t equals 0. Now we need to choose where is x equal to 0. So what I'm looking at is I'm looking at a track that's 200 meters long, so I can pretty much choose it where I want. I could choose it in the middle, I could choose it at the end. And they didn't tell me where do they meet relative to something. And so since they didn't tell me what I was going to go relative to, I get to choose that x equals 0. If they said, how far does runner A run? I'm going to choose runner A as x equals 0. If they said, how far does runner B run? I'm going to choose B as x equals 0. So for us here, I'm going to choose this as x equals 0. Runner B then starts at x equals 200. And somewhere in the middle here is the 100-meter mark. And just based on kind of, a feel for it, if runner A is running faster than runner B, they're probably going to meet somewhere just, so runner A has run a little over 100 and runner B has run just shy of 100 meters. All right, so let's set this up. Let's fill in our information. So our constant speeds made our acceleration 0. That's great because that means that my initial velocity and my final velocity will be the same value. It also means I'm going to use equation number 2. All right, so runner A, I notice starts at 0 meters at 8 meters per second. Runner B starts at 200 meters and moves at 7 meters per second. Now I got to be a little careful here because runner B is running from 200 towards 0. So in order to do that, it has to be moving in the negative direction. So I need to remember that negative sign, okay? So if they're moving toward each other, make sure one of them has a negative velocity. And they are going to meet at some location, and that's the location I want to find. So this is the same value. And because they start at the same time, the time it takes them to start and meet is going to be the same as well. So I'm going to have these common variables of position and time. And so I'll have two equations and they'll have a common variable x and t. So I'll have a system of equations, two unknowns. We should be able to solve it. So the first thing we want to do is cross out anything that's 0 here. So for runner A, x is going to equal velocity of 8t. And for runner B, we're going to cross out anything that's 0. And so only the acceleration is 0. So I have x is equal to 200 minus 7t, or plus a negative 7t, either way. And so now I have my system of equations. So what I'm going to do is I'm going to set those two equations equal to each other since they're both equal to x. And so I have 8t equals 200 minus 7t. Move the 7t over, so now I have 15t equals 200. And so I get a time of 13.3 seconds until they meet. Now, I get to choose. I could put it into either of these position functions because, again, these times are the same. This one looks a little easier for me, so I'm going to plug that time in there of 13.3 ideally because I'm using a number I already calculated. I'm going to store that number, okay? And 8 times 13.3 gives me 106.7. 106.7 is the location on here. Now, because they didn't tell me where x equals 0 and I chose it, when I write out my answer, I'm going to say for that, I'm going to say it's 106.7 meters from where A started toward B. There we go. Now, I would like you guys to go down. There's a practice problem right below here. And go ahead and try. It's another one just like this, runner A, runner B. But they say how far relative to a flagpole. So that should clue you in to where you should choose x equals 0. Also, something that will make your lives a little easier for that one is, in this case, I used meters per second and meters. As long as you're consistent and you used kilometers per hour and hours, kilometers per hour and hours and kilometers, it'll work out. So don't change those numbers. And then go ahead and kind of do the same process, okay? The answer for that one is located just kind of down and to the right. It is 0.2 kilometers west of the flagpole. Oops, west of the flagpole. Okay. So give that practice one a try.